finish up our discussion from yesterday about translations and then go into scale changes today. What I didn't have a chance to talk about yesterday was this idea of what we call a vertical shift. Vertical shift means, the word shift in this context means translation. So anytime we talk about a vertical shift, it means a vertical translation. And we decided yesterday that that was one, or you can also say one up, one up one, something along those lines. A phase shift is basically a horizontal translation. So in physics, when you deal with wave patterns, wavelengths, and things like that, anytime something is out of phase, it means it's off horizontally from where it was before. So they call this a phase shift. All that means is your horizontal translation, which we said here was negative pi over 2, or you could say pi over 2 left. Okay, I will accept either one. So I just wanted to kind of clarify that. Please notice that what we call the midline, and this is going to come in with what we talk about later on, the midline of this particular graph is now at y equals 1. The midline is basically a line you draw that is halfway between your relative maximum points and your relative minimum points. And so you have a midline of y equals 1. That will always match where your vertical translation is. So that midline is always a match of your vertical translation. Please notice that the distance from that midline to the high point or to the low point is 1. So that implies that we have an amplitude of 1 still. And so we haven't really changed. And also, by the way, notice that from high point to high point is still 2 pi. And so the period here is still 2 pi. We have not changed the period of the function. We have not changed the amplitude of the function. All we have changed is the location of the function. And so the point is, all we're doing is moving it left and up. It's not changing anything else about that wave-like pattern. And so this is why this graph looks like it does. Now, I've had in the past, when I've taught this course before, I've had people tell me, well, that doesn't look anything like what our original function looks like. Well, the reason it doesn't is because we've changed the units. We've changed the units from pi's over 6 to pi over 2's. So since we've done that, we've kind of condensed the distance from 3 units along the horizontal axis to 1 unit along the horizontal axis. So that's why it looks much more squished together horizontally than what maybe your parent graphs do. But it really isn't, because the points are really the same distance away. And you can tell that because the amplitude is not changed, nor is the period changed. When we get down here, I've done this already, sorry about that. But when we come down here, all we do once we get to these points is we start graphing them, plotting these points, and then connect our dots. And so this continues on in this sort of a fashion in this direction here as well. But again, I haven't really changed anything. If you take a look at the midline is right here at y equals 2, and I'm sorry, negative 2. And again, that matches that vertical shift of negative 2, or you can say 2 down. And our phase shift is pi over 3, or you could say it is pi over 3 to the right. If you just say pi over 3, I'm assuming to the right, just so you know. Say negative pi over 3, I'm assuming left. Okay. So our midline is still, our midline is y equals negative 2. Our amplitude is this distance here, which is still 1. And the period goes from here all the way over to here, and that is still 2 pi. So, if you take a look at this, this is 7 pi over 6. This is 8 pi over 6, which is 4 pi over 3. 9 pi over 6 is 3 pi over 2, 10 pi over 6 is 5 pi over 3, 11 pi over 6 is 11 pi over 6, 12 pi over 6 is 2 pi, 13 pi over 6 is 13 pi over 6, 14 pi over 6 is 7 pi over 3. So that's where we had ended with our 5 points. You can tell, by the way, that the range here now goes all the way from negative 3 up to negative 1. I do want to point out something. with these sinusoidal graphs, if you look halfway in between these two numbers, you'll notice that you should see that midline, and you should also see the vertical shift. If you go back over here, halfway in between these is y equals 1, and that should match your midline, and that should match also your vertical shift. So I just want to point that out as we continue on with some of these ideas as we go through things. And then the last thing is, what do I do with this guy, because I don't really understand it. This is brand new to me. So notice I've changed the notation from, especially over here, from phase shift to horizontal shift, and there's a purpose to that. A phase shift specifically refers only to sinusoidal graphs, meaning sine and cosine graphs. It does not refer to tangent graphs, cotangent graphs when we get there, cosecant graphs, or secant graphs. None of those others apply. They only apply to sine and cosine. So when I refer to a tangent, a cotangent, secant, or cosecant graph, once we get to those last three, which we will, then I'm going to switch over to the phrase horizontal shift, not phase shift. Okay? So what we know is we know that this is telling us we're moving pi over 2, or pi over 4 to the right. And what this is telling us is we're moving up 3. So what does that have to do with the point? So what I use is I always use these points. I use the point negative pi over 4, negative 1. I use the point 0, 0, and I use the point pi over 4, 1. And I say, okay, if I move everything pi over 4 right and up 3, where would these points be located? So these points would be located, if I move pi over 4 to the right, I'm adding pi over 4 to all of the x coordinates. So this would be a 0, this would be a pi over 4, and this one would be at pi over 2. Because 1/4 plus 1/4 is 1/2. And if I move them up 3, then I'm adding 3 onto the y coordinates. So if I add 3 onto negative 1, I get 2. If I add 3 onto 0, I get 3. And if I add 3 onto 1, I get 4. So I can start to plot those points. So 0, 2 would put me, oops, that's not a very good point, Roars. 0, 2 would put me here. Pi over 4, now I got to pick out a unit of measure. So what would be a good unit of measure to use here? A good unit of measure would actually be pi over 4s, and I'll show you why when we get there. So pi over 4, next will be pi over 2, then 3 pi over 4, and 4 pi over 4, which is pi, and 5 pi over 4, 6 pi over 4 is 3 pi over 2. So these would be good units to use. So pi over 4, 3 would put me here, and then pi over 2, 4 would put me here. But the other two things I have to have is I have to have the asymptotes. I have to have those boundaries for things. Just like we had asymptotes with our rational functions, we have asymptotes for this. So the first asymptote was if I go to the left of the negative pi over 4, negative 1 point, is at x equals negative pi over 2. And the other one was at x equals positive pi over 2. And I like to use these because there's a nice symmetry to them. And so what I'm looking at is I'm looking at where do these things move? Well, these are only x values. So the only thing that affects them is that horizontal shift. Because these are x values. X values are horizontally oriented. So these are being affected by only that horizontal shift. It makes no difference whether you move it up or down because it's a vertical line. And so this would say that negative pi over 4 should be one of my asymptotes, and 3 pi over 4 should be another asymptote. And so if I'm looking at this, then I have one asymptote over here at negative pi over 4. Whoa, that was not a very good line, Roars. I have one asymptote here at x equals negative pi over 4, because this is negative pi over 4. And then I have another asymptote over here at x equals 3 pi over 4. And so the one cycle of that tangent graph looks like this. So if I wanted to duplicate this, if I went to the right, I would go another pi, because the period here, I haven't changed the period on this. The distance between the asymptotes here is pi, and that's the period. So I would go another pi, so I'm in 4, so I'm just going to go 1, 2, 3, 4. And so there should be another asymptote here at 7 pi over 4. And then I'm just going to translate these over another 1, 2, 3, 4 pi over 4s. 1, 2, 3, 4 pi over 4s. 1, 2, 3, 4 pi over 4s. And I get a second cycle relatively easy. If I wanted to go left, then I would do the same thing. This would be negative pi over 2. This would be negative 3 pi over 4. This would be negative 4 pi over 4, which is negative 5, or negative pi, and this would be negative 5 pi over 4. So I would move 1, 2, 3, 4 units to the left, and there should be an asymptote here at x equals negative 5 pi over 4. And then I just translate these points 1, 2, 3, 4 units left, 1, 2, 3, 4 units left, 1, 2, 3, 4 units left. Connect the dots. What you should be able to see is this repetition going on. And so the question is, well, how do we generate all of the asymptotes, because there's an infinite number of them. And so I just always pick a starting point. I'm going to say negative pi over 4 is my starting point. And then we always add the period times k, where k is some integer. So this is always the period k, where k is some integer. Starting point, pick one of the asymptotes, plus the period k, where k is some integer. That defines all of your asymptotes. By the way, that also tells me that the domain of this function is all reals, except x can't be pi over 4 plus pi k, where k is some integer. And that is the domain of this function. For a tangent graph, the range has no restrictions. And so the range is always going to be minus infinity to infinity. Because if you read from bottom to top, that's what the arrows are there for. This goes down forever, goes up forever, and it touches everything in between. So that finishes up our discussion from translations from yesterday. What I'd like to do is I'd like to then go on to scale changes and how do scale changes change things. So, and this is where you have to get used to this. So again, this 2 and this 3, because they're being multiplied or divided, are scale changes. And scale changes change by basically compressing or stretching out away from the axes. So it's either a multiplication factor or a division factor. The 2 is what we call a horizontal scale change because it's inside. And the 3 is what we call a vertical scale change because it's outside of our function. And so the question is, what does this do? And I'll start with the vertical scale change because it's easiest. The vertical scale change is actually a 3, which means it's stretching things out by 3 times as much. And we'll talk about what that means here in a second. Okay. The horizontal scale change is a little tougher because it's actually kind of the opposite of what you see. I mentioned that yesterday. So what you see is a multiplication by 2. And so what this actually is, I don't know what words your teachers used last year. I used the word compressing. It's squeezing together this function by 2, a factor of 2. Okay. And so what is this doing? So this is compressing things together horizontally by a factor of 2 times as much. So it basically is cutting the coordinates in half. So, since this is the cosine function, we're going to go back to our 5 points. So our 5 points were the points 0, 1, pi over 2, 0, pi negative 1, and 3 pi over 2, 0, and then 2 pi 1. And so the question is, well, how does this change those points? And so what happens here is that we're compressing the x values by twice as much, or cutting them in half. So what I'm doing is I'm multiplying the x values. I'm going to do this so you can see it since I'm not here. I'm multiplying all the x values by half. And then I'm stretching things out on the y-axis. So what does that mean? Is I'm multiplying the y values by 1, or I'm sorry, by 3. So again, I'm going to write all this out so that you can see this. Whoops. I want the 0 to be last. Sorry about that. So that the points that I end up with then are 0, 3, pi over 4, 0, pi over 2, negative 3, 3 pi over 4, 0, and pi 1. So if I start to plot this, what you're going to see is you're going to see this. So 0, 3 would put me here. Now, I got to go to pi over 4, 0. So the question is, what's a good unit to use? Well, you'll notice that every one of these points is up by 1/4 of pi. So a good unit to use here would be pi over 4. So that's pi over 4. 2 pi over 4 would be pi over 2. 3 pi over 4 would be the next one. 4 pi over 4 would be the next, and that's pi. And so what I've got is I've got 0, 3, pi over 4, 0, pi over 2, negative 3, 3 pi over 2, 0, and pi, pi 1. And so what I have is I have this graph, and this is what we call one cycle of this graph, and it continues on in that fashion. All right. Now what I'm going to do is I'm going to plot just the normal cosine function over top of this so you can see what's going on. And remember, the points over here are the points on the normal cosine function. So I've got 0, 1, which is here. I've got pi over 2, 0, which is here. I've got pi, negative 1 here. I've got 3 pi over 2, 0, which should be here. And I've got 2 pi, 1, which would be here. So the normal cosine function would look something like this. I'm going to write this out. So what you should see is the fact that we've squeezed this together horizontally by a factor of a half. Because all of these points are now, the x-coordinates are half of what they were, but we've also pulled it apart vertically by a factor of 3, which now means that my amplitude is now 3. Because if you look from the x-axis, which is my midline, up or down is 3 units, and that tells me what my amplitude is 3. Also, the period of this function goes from high point to high point, but now the period is pi, which means it's half of what it was. And that's why I said we're really cutting the x-coordinates in half. So that my range now goes from negative 3 up to 3. So, the scale changes. The vertical scale change affects the amplitude. The horizontal scale change, and it's actually the reciprocal of the number you're going to see inside. So if it's 2 times, it's actually going to be 1/2 times. So it's actually the reciprocal of the number you see is actually the scale change. So we're going to talk about what that means here when we start putting all these pieces together. So here, you'll notice that my scale change on x looks like it's a third. But the scale change here for my horizontal scale change is actually a 3. It's actually the reciprocal number. And the vertical scale change is actually a negative 2. So the question is, what does the negative do? So we're going to take a look at that. Remember, these are multiplication factors. So what this does is it actually multiplies the x values by 3. And this one multiplies the y values by -2. And so if we go to our sine graph, remember there are 5 points in the sine graph. There's the point 0, 0, the point pi over 2, 1, the point pi 0, point 3 pi over 2, negative 1, and the point 2 pi 0. We're multiplying the x values by 3. So this is 0 times 3, and we're multiplying the y values by -2. So this is 0 times -2. We're multiplying the x values, by 3. So we're multiplying pi over 2 by 3. And we're multiplying 1 by -2. We're multiplying the x values by 3. And we're multiplying the y values, multiplying the y values by -2. And we're doing that for all of our numbers, for all of our coordinates. Come on, Morse. We're multiplying each of the x values in each of these coordinates by 3, and we're multiplying the y values for each of these by -2. And so what I end up with the point 0, 0 still, so that hasn't changed. This point now becomes 3 pi over 2, -2. This point becomes 3 pi, 0. This point becomes 9 pi over 2, 2. And this point becomes 6 pi, 0. And so the question becomes, well, what's a good unit of measure to use here? So pi over 2s would be fine. I wouldn't go any smaller than that because that stretches things out. So I'd probably go with pi over 2s here because everything is a multiple of pi over 2. So I would say, well, here's pi over 2. 2 pi over 2 would put me at pi. Here's 3 pi over 2. 4 pi over 2 would put me at 2 pi. 5 pi over 2. 6 pi over 2 would put me at 3 pi. 7 pi over 2. 8 pi over 2 would put me at 4 pi. 9 pi over 2. 10 pi over 2 would put me at 5 pi. 11 pi over 2. And then 12 pi over 2 would put me at 6 pi. And so I'm going to start graphing these ordered pairs. So 0, 0 stayed put. Then I've got 3 pi over 2 and -2. Here I've got 3 pi 0, which put me here. I've got 9 pi over 2, 2. And I've got 6 pi 0. So if I start to graph this function, this is the function I get. So the question then becomes, what does the -2 do? Because this is a negative, you also have a reflection over the x-axis. I often get the question, well, what if the 1/3 had been negative? If the 1/3 had been negative, then you would also have a reflection over the y-axis. So that's what would happen with those points, is you get this reflection image over those two. I'm going to graph the normal sine graph right over top of here so you could see what this would look like. So the normal sine graph would start at 0, 0. It would go to pi over 2, 1. Go to pi 0. Goes to 3 pi over 2, -1. And it goes to 2 pi 0. And so what you can see is 3 things going on. First of all, we're stretching this out away from the y-axis by 3 times as wide as what it was. 3 times as wide as what it was. We're also stretching it out vertically by twice as tall as what it was. And we're also flipping it over because you'll notice that the sine graph goes up from 0, 0 to that first point, but this new one, the one in green, is going down. So we have this reflection going on. The amplitude, since it's a distance, is still just 2. And the period now, though, is much longer. 6 pi. So if you're in physics, you should have discussed sort of what does that do, how does that change things. It changes what we call the frequency of a wave and what that does to the pitch of the wave and all of that. The range here, again, goes from -2 to 2. All right? So, is there anything else I want to talk about that? I don't think so. By the way, this graph does continue. It doesn't stop here, but it continues on in this same sort of fashion. It will go up to 2 over here at -3 pi over 2. And down. This will get over here to, what would that be? 9 pi, so 15 pi over 2, come down here, and then it'll head back up again. And it'll keep going in that wave-like pattern. We'll have this constant waviness to it. And then the last one is this tangent graph. So again, tangent graph. This is my horizontal scale change, but my horizontal scale change is actually 2 here. So it's the reciprocal value. And I have a vertical scale change of -4. So the question is, what does that do? So again, I go back to my 3 points. My 3 points here are the points negative. I always do these three: negative pi over 4, negative 1, 0, 0, and pi over 4, 1. Okay. So what does this mean in this particular case? Well, what it means is we're multiplying the x phase by 2. So we're multiplying 2 times negative pi over 4. We're multiplying 2 times 0. And we're multiplying 2 by pi over 4. And then we're also multiplying the y values by -4. So I've got negative 1 times -4. I've got 0 times -4. And I've got 1 times -4. And so these points end up at negative pi over 2, 4. This one ends up at 0, 0. So that didn't move anywhere. And this one ends up at pi over 2, -4. So if I start to plot those points, I would need a good unit of measure. Looking at the x-coordinates, a good unit of measure to use here is going to be probably pi over 2. So here's pi over 2, here's pi. Here's 3 pi over 2, here's 2 pi, etc. Go backwards, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, etc. And so if I start to plot those points, negative pi over 2, 4 is up here, 0, 0, and then pi over 2, -4. But I also need 2 other objects. And those 2 other objects are my 2 asymptotes. So again, I always go back to the y, or x equals negative pi over 4. X equals negative pi over 2. And x equals positive pi over 2 is my 2 asymptotes on the parent function graph. And so the question is, well, what do I do with those? The only thing, since this is only x coordinates, the only thing that affects them is the scale change on x. And so this would mean that at x equals negative pi and at x equals positive pi, I should have asymptotes. And so I'm going to have an asymptote here at x equals negative pi. Ooh, that was not a good. X equals negative pi. There we go, it's better. And x equals positive. Hopefully I can do this one better. X equals positive pi. So let me write these up again. Negative pi, negative 3 pi over 2, negative pi over 2. And then I just connect the dots. And it looks something like this. That's just not very good, Ross. Let me erase this a little bit up here. Yep. So this is coming out and going that way. All right. Now, this is one period of what you're looking at. And so the period now has changed from 1 pi to 2 pi. The distance between the asymptotes is the period. And my vertical scale change here is -4. Notice I don't have an amplitude. That is, again, just like phase shift from yesterday. The amplitude is specific for sine and cosine graphs. There's no other graphs you're going to see of that phrase in there is amplitude. If you were to ask to replicate this, then because the period is 2 pi, you just move over another 2 pi. So here's 5 pi over 2, here's 3 pi. And so moving over another pi, 2 pi to the right, we'll put another asymptote here at 5 pi. And then I just keep moving over points. So 1, 2, 3, middle will put me here. 1, 2, 3 here. 1, 2, 3, 4 here. So 4 over from each of these points. That's why it's really nice to have these. Nice job, Roars. That's just not a good picture. Okay. And you're going to get that particular shape. And again, the period here is 2 pi. The asymptotes then, again, pick an asymptote to start at. I'm going to pick pi to start at. You could pick any one, it doesn't matter. And then plus the period k, where k is some integer. So again, even though I don't have this here, the domain is all reals except x can't be wherever the asymptotes are. So pi plus 2 pi k, where k is some integer. The range, as always, range is always for tangent functions, all reals. That will never change. So that is two what we call cycles of that tangent function. I just wanted to give you an idea of how scale changes are interpreted. If you have a scale change that's affecting x, those will be inside the parentheses. And that will be sort of the reciprocal value of what you actually see. So that's why the scale change here is a 2. On the outside, anything that's a multiplication or a division is your scale change along y. And that will affect, if you're talking about a sine or cosine, that will affect the amplitude. If you're talking about a tangent, we just say it's a vertical scale change. The asymptotes are always located. Pick one and then add whatever the period is, k, where k is some integer. And that should give you information then about how to graph these. So I hope you have a good rest of your day. I will be back tomorrow. Tomorrow we're going to put scale changes and translations together. And instead of going through all this basic arithmetic, there's actually a much simpler way of doing it. And I will show you that. Well, I think it's much simpler. Let me phrase that. I think it's much simpler. It does take a couple of days of getting used to. And once you do that, you go, oh, I get it. So that's what we'll do tomorrow. We'll review on Monday, and then you have a graphing quiz on Wednesday of next week. Hope you have a good rest of your day, and have a good evening.